So here we're going to be looking at some of the unique properties of water, including a definition of pH here at Tobacco University. Okay, so looking here, water is a polar molecule, and polar means charged. The oil is a lipid and nonpolar, so there's no mixing because it's like dissolves like. In this case, they're two different types of properties and materials. Water has hydrogen bonds, and this helps hold the water molecules together. It's this kind of molecular force here, and we see that dye being clearly polar because it's dissolving in the water. We have cohesion, which plays a role in plants' ability to transport water internally, and adhesion, water clinging to another surface, in this case the leaf surface. So we're looking at kind of the adhesive and cohesive properties right here with the drop of water. Those adhesive properties are what's causing it to stick to the brass rim, and the cohesive properties are what's causing it to kind of stick together and form that nice droplet or spherical shape. So you can kind of see those adhesion cohesion forces together in action here. Look at those hydrogen bonds. Slowly, boop, goes right from there. And we see that same thing with the running water. We see it overcoming the forces of gravity here, but as it gets smaller, those adhesive and cohesive properties become more apparent. Again, that dripping water faucet, showing those hydrogen bonds of water. These hydrogen bonds also produce some surface tension, which is a measure of the force necessary to break those, and that's what allows water striders to stay on the top. We also have specific heat, amount of energy that must be absorbed or lost for 1 gram of a substance to be changed by 1 degree Celsius. Now, the density of water, ice is about 10% less dense than liquid water at 4 degrees Celsius. This is why lakes and ponds freeze at the top first, because ice is less dense. We also see this is the reason why ice floats in a glass of water. Even though it's both water, that frozen state, in the case of water, becomes less dense. This is also why it's important for outdoor pipes should be drained before the winter, because they can burst during that expansion phase, and that burst can cause something that looks like this in the springtime where you have a burst pipe or some issues. Now, hydrophilic is an ionic compounds dissolve in water. It's the solute, like the sugar, and the solvent there is the T, making it an aqueous solution here in this example. Now we have a hydrophobic, which is nonpolar compounds, such as the waxy coating of the surface here, and we see the water beating up on that waxy surface. It's not dissolving, it's trying to get away from that. Now we're going to move on to try to understand pH here at Tobacco University. And we see the nice different colors there, and we're seeing here at a jacuzzi, or a hot tub, and pH is the measure of the hydrogen ion concentration. The scale is logarithmic, so that's kind of important. It's not linear, it's important to keep in mind. This is why when you're going through and testing water here for pH, if it's at 1 plus or minus a point, well, that's a large difference here. A lot of it's based on colors we saw before, and we see it matching up here. You can add buffers to the water. This is a substance that will resist the change in pH. Try to keep it in a target range without it going too high or too low. And again, we see the different colors here. This is a red cabbage example, or there's some other indicators that can also be used. We see acidic levels being pHs below 7 and basic levels being pH greater than 7. Now moving along here, we see a seesaw, and as that pH decreases, we're going to notice the hydrogen ions will increase. So as we reduce our pH, become more acidic, we're going to increase those hydrogen ions like a seesaw. Lastly, pH scale, as I said, is logarithmic, meaning that small change in pH can actually indicate a substantial change in hydrogen ion concentration. Just like these plants are growing in an exponential form, so is the logarithmic scale of pH.